Welcome to Brain Vision.
Okay, so firstly, we need to find the maximum torque that can be applied to shaft BC without exceeding the allowable shearing stress. We can use the formula for torque in terms of shearing stress, diameter, and the polar moment of inertia. So we have T equal to tau times J over T over 2. Now, for a solid circular shaft, the polar moment of inertia J can be calculated as J equal to pi times T to the 4 over 32. Now we can plug the values for shaft VC. So we have tau equal to 60 MPa, that is 60 times 10 to the 6 Newton per meter square. D is equal to 50 millimeter, that is 0.05 meter, and we get J equal to pi times 0.05 to the 4 over 32, which on solving is equal to 6.14 times 10 to the negative 9 meter. Now we can find the maximum torque for shaft BC. So on putting the values, we have T equal to 60 times 10 to the 6 times 6.14 times 10 to the negative 9 over 0.05 over 2. And on solving this, we get T equal to 14.736 Newton meter. Now we need to find the required diameter of shaft AB, and we can use the same formula for torque, but this time we need to solve for the diameter. So we have D equal to 2 times T times J over tau. So on putting the values, we get D equal to 2 times 14.736 times pi times T to the 4 over 32 over 90 times 10 to the 6. And on solving this, we get D equal to 0.101 meter, or we can say 101 millimeters. So the required diameter of shaft AB is 101 millimeters.